Namaste friend, myself Anand Singh. I am the head of Civil Department Diploma, second shift, Department of Technology Parshi. Now today we are conducting the lecture on the center of gravity. Let us start with this. Due to the lockdown period, we are conducting this lecture online. The content are useful for the first year civil and mechanical diploma engineering student. This is also useful for the first year BTech all branches engineering students. This is also useful for the student who are preparing the competitive examination like MPC, UPSC and GATE examination. Now let us see what are the content we are proceeding for this one. We are considering for the contents are center of gravity, what is meant by centroid, method of the for the center of gravity, center of gravity by the geometrical consideration, for the plane figures, symmetrical sections and unsymmetrical sections. Now, what do you mean by the center of gravity? In this method, the center of gravity is the point may be found out in a body to which the result of all such parallel forces act. This point through which the whole weight of body acts, irrespective of the position, is known as the center of gravity, briefly written as C. It may be noted that every body has one and only one center of gravity. The center of gravity can be defined as the point to which the resultant of force of gravity of the body acts. Remember, the center of gravity can be defined as the point to which the resultant of force of gravity of the body acts. What is meant by centroid? The centroid is the plane figure like the triangle, quadrilateral, circle having the only area but no mass. Here there is no mass considered, but in the center of gravity, the weight of the body or the mass of the body is considered in the center of gravity. And in the centroid, there is no mass concentration. The area is only considered. The center of area, the area of the such figure is known as centroid. The method of finding the centroid and center of gravity is same. There are the two methods: geometrical method consideration, moment, and graphical method is also there. Now these are the some of the figures is considered over here. If you see here, it is a rectangle. It is symmetrical about this L by 2, H by 2. Now here this triangle, if you are considered, it is symmetrical about AD, B, and CF. These are the some of the common figures. Trapezoidal, H by 3, B plus 2A, B plus A. For the semicircular, 4R upon 3 pi. For the circular section, hemisphere, cone. Now let us see some of the basic common figures. Now here triangle. Here the triangle is B H by 2. CP location H by 3. For the semicircle, area is pi r square by 2. CP location is 4r upon 3 pi. For the quadrocircular, area is 4r square by 4. CG is 4r upon 3 pi, 4r upon 3 pi. Section of circle, area is alpha r square. CG is 2r upon 3h, alpha a. Parabola, area is 4ah upon 3, CG is 3h by 5. Semi-parabola, area is 2ah by 3, CG location at x, 3a by 8. For y, 3h by 5. Parabolic spindle, area is ah by 3. For the x centroid of for the x bar, 3a by 4. For the y bar, 3h by 10. These are the common figures generally used for the analysis. Now, center of gravity for the plane figures. Plane figures means such as the T section, I section, L section, having the only area but no mass. The center of gravity of such figure is found out by the as similar as the solid bodies. Now let us see how to find out by using simple problem. But for this we require some formulation. Now here this x bar formula and y bar formula is used for finding out the center of gravity of any geometry of any shape. X bar is equal to A1 plus 1 plus A2 H2 plus A3 H3 and so on, divided by total area A1 plus A2 plus A3 and so on. Y bar is equal to A1 Y1 plus A2 Y2 plus A3 Y3 plus so on, divided by total area A1 plus A2 plus A3 and so on. Here A1 A2 A3 are the area of that particular figure. Y1 Y2 and H1 H2 are the corresponding respective orders of that particular figure from the origin. The center of gravity of the symmetrical section. Now, some of the figures are symmetrical about either x-axis or either to the y-axis. Now, let us see some problems which is symmetrical about x-axis or y-axis. Now, let us consider this figure. The centroid of this figure, the P section is there. The width of this P section is 100, the depth is of 150, and thickness is of 30. And it is symmetrical about what? It is symmetrical about y-axis. Now let us see how to find out the centroid. Now this figure is symmetrical about y-axis over here. It means that we have to find out the y-bar, the location of y-bar either from the bottom or either from the top. Here we are calculating from the bottom. Now it is divided into two parts. Upper rectangle A in CH and lower rectangle B in FG. Now here consider upper rectangle A, B, CH. Here this rectangle is 100 into 30, 3000 mm square. All the dimensions are in here, therefore this area is mm square. Now Y1 is the location of centroid from the bottom to the center of this location. This 150 minus 30 by 2. 150. Now here the distance is y1. Here is 150 minus 50 by 30 by 2. This is 135 mm. Now similarly consider the lower rectangle over here. Area of this rectangle will be, now out of this 150 already we are using. 30 means this lower part is of 120. 120 into 30 is 3600 mm. Now here y2 is the distance from bottom to the center of this lower rectangle. The distance is y. Now 120 divided by 2. Out of this 120 divided by 2 is 60. Now once you will be getting the area and the y1 y2, only simply you have to put this value in this formula. Y bar equal to A1 Y1 plus A2 Y2 divided by A1 plus A2. A1 is 3000, Y1 is 135, A2 is 3600, Y2 is 60 divided by total area 3000 plus 3600 means by calculating you will be getting 94.1 millimeter. This is the centroidal location from the bottom. You will be getting the center. Now similarly we have to see the another problem, unsymmetrical section. Now let us see some unsymmetrical section. It is not symmetrical about x-axis and y-axis. Let us consider this unequal angle 100 by 80 by 20. Here guys you have 100 length, 80 length and thickness of the whole section of 20. Now it is again further divided into two rectangles. One rectangle 1, rectangle 2. Now here area of the rectangle 1 is 100 by 20. 100 by 20. Now the CG location of that particular geometry of the origin that is considered over here. X1 is 20 by 2. It means we have to consider this distance either from the left or either from the right of that particular section. We are testing here from the left of that particular section. Left to the center of this particular figure is 20 by 2 is 10. Now here y1 is the location of the CG of this particular figure from the bottom of that particular figure is 100 divided by 2 is 15 mm. Similarly for the another rectangle, out of this 80 already we have considered this 20, therefore the remaining part is of 60 into 20. This 80 minus 20 is 60 into 20, it becomes so 1200 millimeter square. Now here x2. x2 is the location from the left to the center of the particular figure. This is 20 plus the 60 by 2. It becomes a 20 plus 60 by 2, 50 millimeter. And y2 is the from the bottom to the center of the figure is 20 by 2 plus 10. Now simply you have to put this value a1, x1, y1, a2, x2, y2 in the following formula. Now let us consider first x bar a1, x1 plus a2, x2 divided by a1 plus a2. a1 is 2000, x1 10, a2 1200, x2 15 divided by total area 2000 plus 1200 by calculating integration 25 is the x bar. Similarly, y bar a1, y1 plus a2, y2 divided by a1 plus a2. a1 is 2000, y1 is 15, a2 is 1200, y2 is 10 divided by 2000 plus 1200 and by calculating integration 35 millimeter. Then it means that each of this particular angle section or L section is located at x bar equal to 25 meter and y bar equal to 33 millimeter. Thank you for listening to this video.